again to all the participants, and thanks for joining this session. Uh, yeah, let me start my presentation. Please let me know once you can see my screen.
Yes, sir, it's visible.
Okay, it's visible as a full as a presentation.
Yeah.
Okay.
Now it's visible full screen.
Okay. So as indicated, this is a joint event by AICT, ATAL, and BMS College, and we are primarily supporting the event. Uh, uh, Along with me, I have got my colleagues Ritesh, Ajaya, and Monisha, who will be taking some of the sessions during the course of this event, and there have been also key developers and contributors for quite a bit of activities that we are working on in terms of AR and VR. So towards the end, I'll give you an overview of the event. What are the different components that we'll be going through. And initially, let me start with a bit of a motivation. Why really we should be looking at AR, VR, and what's the benefit? So the agenda for my talk is introduction and motivation. Then we'll get into some sort of a statement and objective of the development that we have been working on. I'll give a very high-level overview of the VR operator training simulator architecture, and each of these components is what my colleagues Ritesh, Ajay, and Monisha will take you through on the development front. So we'll talk about the development tools, the process simulation as well as the VR environment. We'll also talk about one of the environments implementation that we have done, which is Marvel. So we'll talk about the architecture there. We have got one very nice example of control with interacting heated tanks. So we'll discuss that and what components went there. Then we'll go into the results, and finally we'll talk about what is it that we'll be looking at in terms of the course plan. Let me actually, normally I don't do this, but I thought it might be a good idea to do a bit of a video. So I picked up one very nice video from
Sir, can you, audio is muted. Hello, sir.
Also keep VR alive.
Wow,
looks like we made the right call. At a time when headset shipments.
Okay, now it is okay.
Virtual
Yes, sir.
reality hasn't exactly seen the booming success in gaming and entertainment that was once expected. But this VR has a totally different purpose: keeping workers safe.
I'm going to go ahead and say evacuate for half mile.
It could also keep VR alive.
Wow, looks like we made the right call.
At a time when headset shipments have been down 4 of the last 5 quarters, and just a month after IMAX announced it will close all its VR centers this year. Market forecasts predict spending on virtual and augmented reality headsets for training is expected to reach $2.2 billion by 2022. And companies like startup Pixo VR are taking notice.
I think we learned our lesson doing mobile apps, that it's much more difficult. There's not, the budgets aren't necessarily there, and it's made a lot more sense for us. Push your hands. Yeah, a little bit. Yeah.
Pixo VR made the switch 2 years ago from creating video games to creating training modules.
Obviously flammable, explosion risk.
Like this one, which teaches first responders how to identify and react to explosive chemical leaks.
VR provides an opportunity for people to train in environments that otherwise are impossible. Far too risky, far too expensive.
By simply putting on an HTC Vive headset, workers can experience life and death situations that are impossible to safely recreate in real life. There we go, going up. Like a rickety 15-story construction site without solid scaffolding. I'm really high up. Oh my gosh. You make a decision. I think I'm going to hook it to this rope up here. And suffer the consequences if you choose wrong. Oh my gosh. The sensation of falling is so real, It's immediately clear this experience will stick with me. I'll remember that fall and which safety measures I should have followed far longer than I'll remember any PowerPoint slide. That's all very real. There's research to back this up too. One study found students had 30% better knowledge retention 2 weeks after learning with VR as opposed to traditional education methods.
There's a whole bunch of research that shows that if you are a human and you interact with something in 3 dimensions, as opposed to just looking at it on a piece of paper, you understand it much more profoundly and fundamentally. It's just the way that our brains are wired.
And there's a big need for more effective training. Last month, the National Safety Council announced that preventable workplace deaths have been on the rise in the U.S. for 3 years in a row. Essentially, 14 people every day leave their homes for work and don't come home. This is absolutely unacceptable, and there are things that we can do about it. Technology like AR and VR are really going to engineer the human error out of these equations, but we've got to start to really do the research to understand what's working and what just has potential so that we can give employers the best resources available to help make their workers safer. This year, the NSC will begin a 2-year, $500,000 research project to study the effectiveness of VR and AR, among other technologies, for reducing workplace fatalities. Workplace fatalities and injuries have consistently cost society more than $150 billion every year. So while there certainly is upfront costs in investing in new technologies, those technologies will save companies in the long run with a reduction in fatalities and injuries. One startling number, 713 workers fell to their deaths in 2017, a number that Hurwitz is hoping will go way down once workers start training on PixoVR's fall prevention module.
And hopefully we'll see the numbers go down for accidents, certainly fatalities. You know, it's something that the entire company has got behind because we know we're making lives better.
Hurwitz is in good company. Most of the major players in the VR space have begun using their software and their headsets for workplace training.
The return on investment in the commercial space is so profound for some of these key scenarios, like remote assistance, like laying out physical spaces, like guiding someone through a complex process, that these things literally pay for themselves very quickly. So that's where we're seeing the most interest in investment right now.
Microsoft's HoloLens, technically an AR headset, has been added to Trimble hard hats on construction and mining sites to enhance worker safety. It's used by 20,000 ThyssenKrupp elevator technicians to make sure they're safely strapped in when making repairs. Chevron technicians wear HoloLens for otherwise precarious oil refinery repairs, and Japan Airways mechanics use it to stand inside a virtual jet engine while it's running to learn how to safely maintain it.
Folks that have a tool belt or a hard hat have not benefited as directly from the digital revolution. So mixed reality, we think, and devices like HoloLens are one of the trends that can really bring the benefits of the digital revolution to whole new categories of people that haven't benefited before.
Even the Army has turned to VR and AR training. In November, Microsoft signed a 2-year, $480 million military contract with the U.S. government to deliver up to 100,000 HoloLens headsets for use in combat missions and training. And the list goes on. Samsung's Gear VR headset is being used to train workers on new production lines at Magna's automotive parts manufacturing plants. DHL is using Google Glass in its warehouses. Pacific Gas and Electric is using Heartwood 3D VR to teach employees valve assembly. In 2017, Facebook launched Oculus for Business, offering bundles of their Oculus Go and Oculus Rift headsets to businesses like Tyson Foods, Walmart, and Verizon. Tyson Foods, in particular, had some promising results. They used VR modules by Menlo Park-based Striver to train its workers in safety and hazard awareness, and they saw a 20% reduction in worker injuries and illnesses. Verizon stores plan to have 15,000 of its frontline employees put on Oculus headsets and be confronted by armed robbers. A high-intensity Striver simulation to prepare them for worst-case scenarios. And now Walmart is using Striver's virtual training modules in all 4,700 U.S. stores, training more than 1 million employees with 17,000 Oculus headsets. A major hurdle that's plagued VR since its early days. Will all those employees get nauseous once they strap on the headsets?
With Walmart, specifically all of our customers, we work really hard to make sure we're putting you in pretty much a static decision-making moment. We're not moving the camera. We're not running you down an aisle. We're making it very, very comfortable for the employee.
Striver has raised $21 million in venture funding and has secured deals to bring immersive learning to companies like BMW, JetBlue, Fidelity, and even the NFL.
It puts you right in the field.
And PixoVR, their fall prevention module is just the beginning. Now, they're working on programs to prevent the other three most deadly accidents on construction sites: electrocution, being struck by heavy objects, and caught between things.
The market is definitely starting to show momentum and change for the better. Over a year ago, 2017, the question was, what is VR? Today, the question is, what do you have to buy? And they're also under the belief now that VR training is a great solution for them.
Hi. So let me come back to my presentation. You can hear me? Hello, Dr. Desai, you can hear me?
Yes, sir, you are audible.
Yep, okay, good. So, we thought that, we'll start with sort of a motivating video. Here, they talk quite a bit about safety, prevention of accidents, etc. In addition to that, of course, just the normal operation of a plant. Manufacturing in that sense is sort of, not many people are getting in. It's sort of, not with the IT world. It is, not probably not the first choice of many of the students, etc. So, how do we get them to be motivated? How do we get them to get into this field, etc.? From that point of view, AR, VR really makes a lot of difference. So let me actually go on with my presentation now. And as you would have seen that, lot of many major companies, OEMs, etc., have started now using AR, VR solutions. So some of the major OEMs like ABB, GE, Honeywell, Siemens, Yokogawa, Volvo trucks manufacturer, Tata Motors, they all, and including all the engineering companies. In fact, I've just given a few names: engineering and technology companies, Infosys, Wood. Many companies have started sort of, rolling out AR, VR solutions for many of their product lines for training, etc. So as you can see that, this is something which is growing. You would have also realized in the presentation or in the video, they have been talking about the fortunes of AR, VR sort of going down in the gaming industry, but it has now started picking up in the industrial world. And that is something which is very interesting for us, especially when we are from the engineering and technology background. So this particular workshop will help you in going forward in two different modes. One is to set up your own VR development lab. So, which would be a multidisciplinary lab. You would have mechanical, electrical, chemical, instrumentation and controls, electronic engineers who will form the domain backbone. You'll also have people from information science, computer science, graphics, etc. And you can actually form a VR development team within your colleges or in your organizations. It would be a great platform for for people to learn. So one of these the growing technologies, and it would be sort of blending the technical knowledge across the whole spectrum. So that is one more where looking at all the components that we'll share with you over these 4 to 5 days. You can think of setting up your own VR lab, where you can over the 2 to 3 years, you can sort of start teaching your students how do I make animation, how do I make drawings, how do I connect it to a simulator, how do I build a model of a tank or a model of a turbine or of a generator, etc. You can also set up your own VR training lab. So, for example, which will give you, like what Dr. Desai was saying, an industry-like experience. So you can have tanks, you can have a manufacturing plant, and then you can get your students to sort of conduct very specific experiments there. It's not limited by funds, it's not limited by space. It's actually, the limit is your imagination. You can set up as a much flexible environment. Normally, when you bring in hardware of a control system or of some physical system, you get constrained by the design specs that you had given to them given earlier. Now, if you want to change the size of the tank, or you want to have different students do different kind of experiments, you're always going to be constrained to what that mechanical setup will do. So those kind of constraints can go off. You can, very quickly, using software to change to different experiment conditions, different environments, and in the same setup, sort of give a much varied experiment. In fact, even the operating conditions can be different. So you can literally ensure that every experiment for the same setup is different, and essentially, so that will also allow your students to get a much wider experience, etc. And ultimately, it's an entertainment. So you are going to finally implement technical education with an experience of gaming. So these are some of the key reasons and motivations for going for AR VR as a teaching platform. Build up your own lab where you can sort of teach how to do VR, which is actually a very skill in demand out in the outside world, as well as use the same environment to teach students on your technical knowledge in an industrial kind of an environment. In case you do have any questions, please feel free to post them. I can take them as the discussions go. So let me start with a few definitions. So what really is VR? So VR is basically an artificial environment that is created with software and presented to the user in such a way that he suspends his feeling of reality and accepts that what is there inside the VR environment is real. So on computer, VR is basically experienced through sight and sound. You can also put in things like vibration and feel, etc. That's something that is going on, and those are the extended reality experiences. And an operator training simulator is basically a training simulator with in which in the background is a dynamic simulation about the industrial process. So it sort of makes the whole environment interactive. In fact, what you see down is an industrial environment, or it's a VR setup that we have developed for BMS College through VGST. And in fact, the picture that you see is of Ritesh, who is one of the resource members or the faculty members of this course. So quick recap of the motivation. So I hope I have sort of tried to convince and you on it's really an essential activity to ensure efficient and planned safe operation. There are, of course, traditional methods of doing it. You can sort of train people with theoretical guidance, with hands-on experience, with offline dummy machinery. And of course, there are computer-aided training simulators, which are 2D, which are available. And as you would have seen even in the video, the biggest, highest retention capability turns out to be when you get the feel of it, and the VR, which is the latest edition, really does that. So VR's immersive capabilities makes its effectiveness equivalent to training on a live machine without the associated risk. So in the real life, you really cannot sort of create safe environments of some explosion or etc. So whereas in the VR world, you can very easily create those environments and sort of get the participants to learn how to sort of react to such events. It has quite a bit heavy on the recreation industry. Like what I was saying, it's gone a bit up and down. In the industrial environment, it is a bit complex because you're talking in terms of physics. You're talking of things happening in the real way. So few things that you have to handle. But there are enough good simulators available to take care of the physics of a system. That said, on the whole, VR can be a bit expensive, especially if you're going to a third party. But there is good amount of open source framework available, and and if things are done in house or with startups, etc., then you can sort of make it much more economical. And it has sort of in the training world becoming a game changer. So going on to the next slide, let me just talk about quick problem statement that we have been working on. So we have been working on to develop a VR-based operator training simulator using open source technologies. So almost all the technologies that we'll take you through in next 4 to 5 days are open source. There's one component which is sort of proprietary, and we are at this moment looking for an alternate to that. And as far as possible, use the gaming technology, because gaming has been evolving very fast, and a lot of technologies have been built. So how do we pick up those technologies and put them into the training simulator? We'll also demonstrate the training simulator that we have built, Marvel, which is Modelicon's augmented remote and virtual engineering lab, for which can be used for this purpose. So some of the overall applications of AR VR that we can summarize to is for education and training, gaming and entertainment, advertisement, sort of creating that experience for people, e-commerce and retail, interior design, and real estate. So you can sort of get people to get that full feel of it, the experience, without really going to the site. Tourism and travel, healthcare, communication and collaboration. You can actually start doing interactive collaborative activities, and of course manufacturing and maintenance. So a good wide variety of applications, provided you have a right setup and environment. Excuse me, let me just drink some water. So like what Professor Desai was saying, you want to give your students an industry kind of experience, and all of us have that intention, but it's always the question of feasibility. To put up a small pilot plant or small manufacturing facility to train students is always going to be difficult. You can send students for industry visits, etc. But those are just visits. You're not going to get hands-on experience for the students there. The VR has the potential to change this scenario. So VR can gain experience of starting up a plant, running a plant, interacting with it, taking care of unsafe conditions, optimizing the plant, etc. So that becomes a big deal, and over the time, I'm hoping that you would be able to colleges can collaborate with industrial companies who have quite a bit of simulation packages available for their plants, modify them so that they become sort of non-proprietary, and then you can connect it to the VR world. So the students who who come out will actually have a very nice plant experience, interactive and used the plant experience. So over the time, it can become a win-win situation for the industry. So, and the biggest thing is like what was said before, it has got a very high retention capability, and that really is something which is very special. So for education, the AR/VR solution that we have basically has 3 primary components. There is this whole virtual reality user interface. In fact, Ritesh and Monisha will take you to some of the components. There is a mathematical simulation of the process. That's the other component which Ritesh will talk about it in detail. And then we have the final HMI or the visualization, including interfacing with the controller, etc., which Ajaya will be talking about. And of course, in addition to these 3 components, we have one more component which sort of integrates all of this. How does this VR interface communicate with the simulation and then communicate with the PLC? So we'll have a very special session by Ritesh on that topic also. So So the architecture, like I was talking about, the process simulator and the HMI client, the simulator is actually in the heart of it, where you sort of simulate the plant in real time. It will pick up the input values from the VR as well as from the PLC, and and mimic the behavior of a plant. The output will be that behavior, like for example temperature rising, speed of a motor increasing, etc. And it will be displayed on an HMI screen. And the other two components are, of course, the VR headset itself and the PLC. So this is a rough, very high-level architecture. We'll talk more about the actual implementation in the subsequent slides. And of course, over the 4 days, take you through each of these components in detail. So on the back end, the main two components are Open Modelica, which is the simulator. So we have been using an open source simulation environment called Open Modelica. It's based on modeling language called Modelica. So the good thing about Modelica is that it's a multidisciplinary language. So in the same environment, you can build models with mechanical, electrical, chemical, controls, electronics, all components together. So you can start understanding the interaction of all these domains within the same plant. It's a language which has been built for modeling such systems. Up till now we have been using a borrowed language. So when you say you're using Fortran or using C, C++, those are languages which have been built from the IT point of view, from programming point of view, but they were not languages built from modeling of engineered systems. So that was something which was sort of noticed as a drawback in the 60s, 70s, and 80s, where all of us were using borrowed languages, and so that is when the research sort of took off and said, what's the language that the engineers use, and that's how Modelica started. And Open Modelica is an implementation of Modelica, which is open source. In fact, we have been also very actively involved in the Open Modelica development framework, which is basically in Sweden. And some of the members like Ritesh, myself, interact with the teams quite a bit. In terms of the PLC and the control system, we have been using Codesys, which actually is a proprietary package. And the reason we are using it was because we wanted to get a quick solution. But at this moment, we are looking for an alternate open source solution. So that is the control modeling environment. In terms of the virtual reality environment, we have two packages which we use. One is Blender. Blender is a free open source 3D computer graphics tool set, which can be used for creating animated films, visual effects, etc. And we'll take you through a couple of sessions on Blender, which will be taken by Ritesh and Monisha. So we'll sort of create a a ball, a bouncing ball effect, etc. For which sort of you can sort of learn how to use it. And Unity 3D is a cross-platform gaming engine, which has been built by Unity Technologies. So it is available for non-commercial use free of charge. And it is programmable. So whatever you build in terms of drawings or figures and components in Blender, you can finally import them into Unity 3D and convert them into some programmable movements. So the Marvel Automation Lab contains, of course, all these components. Some of the key features of this is basically the 3D environment is done with Unity 3D. Then we got the Open Modelica and Codesys. You can operate that plant in both auto mode as well as manual mode. Okay. When you're doing in the manual mode, it becomes much more immersive. So the student can go into the plant and sort of open and close valves, increase the power level of the heater, etc. And in the auto mode, he or she can learn how to operate a control system. And of course, it is connected to the VR as well as the simulator, so he'll get a real feel of how things work. So this is a very specific implementation for Marvel, where Open Modelica, we just talked about it. So some of the components are, we use mathematical model in Modelica, we use OPC UA for communicating between Modelica and control system, etc. We have built our own OPC UA client and a UDP client to basically communicate with the VR world. On the right-hand side, the control system controller is basically implemented in Raspberry Pi with the help of coaches. And we'll talk about this in more detail in the subsequent sessions. And on the left-hand side is basically a VR headset. Presently, we have used Android-based VR headset, but we are thinking of moving over to some of the things that you saw in the video, like Oculus, Quest, etc. So this is the quick architecture that you would be seeing over the next 4 days. Okay, and let's talk a bit about the simulation environment. So we have picked up a very nice classical control problem to sort of teach students. So it contains 3 tanks. So it's a basically level and heating control. 3 tanks with a source and a sink, and they are interacting. So by interacting, what it means that the levels in each of these tanks is not only dependent on what is going in and what is going out, but is also dependent on the heights of the other tanks. So the flow here will depend on what is the height here and what is coming in, and similarly. So in case if I do a sudden leakage here, you'll find this level goes down, not because the source has changed, because the height in this tank has changed. So as you can imagine, this actually increases the level of complexity in the control problem, and that is that sort of now can allow your students to do some very simple level and temperature control to control of interacting processes, etc. And you can sort of initiate leakages in different tanks and sort of get students to learn control in presence of disturbances, etc. So how is the architecture? So the architecture is you have the process simulator here, and that is talking through UDP to the VR headset, and you can it passes on information from the simulator like the tank levels, the tank temperatures, flow rates, what's the mode of operation, is it auto, manual, etc. The simulator also passes on to the HMI the same values, temperatures, tanks, level, flow rates, etc. The HMI has got the controller also. So from there, you'll get the valve positions, the power levels, etc. That's basically the controller feedback, which goes back to the simulator. And then the simulator basically acts on it and gives out the next level of levels, temperatures, etc. The simulator is basically a dynamic simulator. And the same values that the HMI is passing will be also seen by the VI, the VR, right? So this is how the whole architecture is. And like what I said, we'll be going into each of these components in detail over the next 4 to 5 days. So this is in fact the simulation environment in Open Modelica. So what you saw here in the pictorial form is how this is implemented in a model. So you got these 3 tanks connected, and then you got a source and a sink. And what you see on the top is a jumble of lines is basically the communication framework for the VR as well as for the controller. Okay. And the way it is built is it's basically built as a library in Modelica, and each of these components are actually sort of object oriented. So you can sort of drag and drop, and you can literally create your own configurations out of this. This is in fact the Blender and development environment. So each of these tanks have been created as static images and sort of implemented. So you sort of sit and create all these components, and then you put them and export them or import them into Unity 3D, which sort of creates the animation and sort of you can make it programmatic. And this is how you would see when the whole thing is integrated. So In fact, Ritesh will take you through this in more detail. So we got 3 tanks. You got all the instruments, gauges. This is the power supply panel with power levels to each of these tanks for heating and cooling. You got the valves which can be controlled automatically through the PLC or through manually in the VR world. You have got the gauges for the flow, for the temperature. There is a tank on the top, which is the source, and there's a tank in the bottom, which is a sink. And as you move and you point to any of these components, you'll be able to see what are the tank levels, what are the temperatures, flow rates, etc. So this is basically what you would get when you integrate Open Modelica, Blender, Unity 3D, and the controller together. Okay, so these are different views of the same system. So you can as you can see that you can get and you'll get a feel. You'll also unfortunately this has turned out to be an online session. As Dr. Desai was saying, we were planning this to be on site at that time. Then you'd have got a chance to play with this, and you would have got also the sounds of an industry going on. So we have sort of created. If you are standing here, it would be like as if you are standing in a plant. So the HMI visualization, let me spend a little bit of time on the control system. So this is something that we have implemented in courses. So you have 3 tanks, and then out here you see the temperature and the level of each of these tanks. On the bottom is basically where you can train or teach students how to control. You have the temperature controller, the level controller. You can sort of have the PID settings for each of these controllers. Out here you can see you can change the valve type. So you are equal percentage, linear, etc. So you can actually, using this environment, create a different different sort of scenarios for the students. You also have the provision for sort of deciding the leakage type. So the orange line that you see is basically the leakage. And the way you can, the lab can be set up is by what you see on the right-hand side, where there is a student login and an instructor login. So let me see. So there is when an instructor logs in, he or she gets this page as additional, where you can now start setting up different dimensions of the tank, different control valve CVs, different powers for heating and cooling. You can create different leakage profiles, etc. And as you can see, the advantage with this is your experiment now is not single experiment for all students, single tank system for all students, but each student can have his own and her experimental setup. So you can create now things like, this is a small tank, this is a big tank, this is a very big tank. How will the system behave? Or this is a very big tank, these 2 are small tanks. How will the system behave? So you can start creating this kind of setups and see how the control the systems behave in different manner. And of course using both using the VR so that you see what's happening inside, as well as in terms of simulation. So those are the things that you can do. So once the instructor saves the parameters, then the student gets in, and then his or her job is to sort of control the level or control the temperature on of this system. You can make it sort of simple system by saying, okay, now let's just focus on 1 tank, or you can make it relatively more complicated by saying let's focus on all 3 tanks with just level, or you can make it into a postgraduate level control course where you say let's make it as all 3 tanks with all levels and all temperatures. So now you've got a very complicated interactive control problem, which requires good amount of control, capabilities to solve it. So in the same setup, same framework, you can see the huge amount of variety of training programs that you can create for your students. So that really is the big benefit of using AR, VR kind of an environment to set things up. Let me pause at this moment here to see if there are any questions.
Any questions from participants?
Okay, then let me move on. Okay, so the other thing that is important in this whole framework is how do we make all these components talk to each other. So you have the VR headset, you have the in the PC you'll have the Open Modelica dynamic simulator, as well as you'll have the whole Unity 3D development engine, and then you have the Codesys Raspberry Pi PLC. So the way we have established the communication so that the whole system works as in an integrated common platform is using OPC-UA framework here. So in the Open Modelica, there is an OPC-UA framework to communicate with OPC-UA client, which has been built in-house by us. And that client also talks to Codesys, which is using OPC-UA. And in terms of on the left-hand side, you will see that the communication between Open Modelica and VR headset happens through UDP, which is again an in-house built setup. And between VR and the controller is basically Bluetooth. So we would be talking about this in detail. So Ajaya will take you through this whole Codesys framework. Ritesh will talk about these communication platforms as well as the training platforms, and we'll have Ritesh and Monisha talk about Blender and Unity 3D. So that's the whole communication platform. So the next step is how do I initiate the program? How do I sort of set up the whole VR framework? So for that, there is a very simple app that has been built, which runs on Android phones. So that is the one which can launch the simulation and the web HMI by specifying the IP addresses, etc. Okay, and then once you have established the connection, then you can sort of launch the launch the simulation and then the HMI. And once the whole thing gets done, then the experimenter, the instructor can basically set the experimental facilities like what I was telling here. So he or she can sort of set up the experiment for the students and then hand it over to the students to run the experiments. The other big advantage is that once the experiments are done, the student has got the capability of, let me see if there's a screen to do that. Yep. So there is the student has the capability of logging the data. So all the temperatures, levels, etc. sort of get logged. They will be saved here, and then finally they can be emailed to the student. So the student's job will be route the experiments, collect all the data, and then go home or go to the class and sort of do all the calculations, do all the analysis, and then submit the report. So as you can see, it literally can work the way you are running the experiments today, where you sort of hand over some the experiment kit to the students. The students goes, sets it up, does the experiment, collects the data, does his calculations, creates reports, and then submits it back. So the whole environment can be done here. The big advantage, of course, here is that each experiment can be unique. Some of the additional things that we have put here is like to ensure that if when things are running, you get a green light. If something gets disconnected, for example, if this gets disconnected or this gets disconnected, then the student will get an indication here that there is a problem in the connection. And you can operate in both auto and manual mode. When you're in the manual mode, you are working in the VR world. When you're in the auto mode, you are working in the control, the PLC mode. So this is the whole framework. The simulation also is interactive, so you can start, stop, pause, etc. And of course, the final thing is, and then just like in an industry, you will be able to, the student will be able to see the plots. So he or she can see the trends. Like for example, this is the wall opening and closing, as well as this is the value of the level. Okay, Here, basically, this is the temperature heater profile. You'll see the temperature profiles here, and then you can see all the profiles in one shot. So just like an industrial environment, you can create the screens, etc., which sort of mimic the actual plant, and sort of set up the experiments. This is how you would be seeing the tanks. So in the phone, which is connected to the VR headset, you would see these two screens, but when you see it in your headset, you'll see them as 3D. And then, of course, there is a joystick available with the help of which you can sort of navigate yourself, or the student can navigate himself or herself through this whole setup. Open and close these valves. Increase the heating levels, etc. So this is the whole framework. So what can we do with this? What kind of use case scenarios can we look at? So in this particular case, we have set it up as an end-to-end process control lab. So the first thing that the students can learn is to create this first principles dynamic model for connected tanks, do the mass and the energy balances, first operate at steady state operation, and then and then learn how do I do linearization, how do I create transfer functions of different orders, etc. Then the student can sort of do experiments with the tank in a manual mode in the VR world. So he or she can open and close the valves, increase the heating parameters, etc., and learn identification. So using the profiles that he or she would get when he or she does step change in the valve opening or the power levels, he or she can then use that information to create, find out what are the parameters of the plant. Okay, and then you can sort of do control system design of varying complexity, like what I was saying before, integrating control level, temperature control, control system for higher order transfer functions, interacting control, etc. Then you can sort of initiate leakages in the system. So you can sort of say, what happens to the controller, once suddenly there is a leakage in the system. You can teach students different types of control valves, equal percentage, etc., linear valves, etc. And of course, like what I was saying, each group can have different parameters. So it sort of in some sense also prevents just taking the report of someone else and using it, because the whole system might be different for you. So that's the overall framework in which we can use. Okay, we are of course planning to sort of develop it further. So the current implementation is in Android phone. Now we are going to move on to Oculus Quest, so that you can sort of also get the spatial awareness. The VR technology combined with industrial provides a great scope for manufacturing industry, so you can move it to the industrial environment. We want to sort of do hardware in the loop with connecting sensors and actuators. We also want to sort of connected tanks. We want to go to the electrical systems, mechanical systems, turbines. So those are the next things we can do. You can sort of start teaching students about IIoT framework also within this. And and this can be something which would be of great help to both small industry, colleges, as well as to the students. I would also like to just quick acknowledgement. Would like to thank BMS College and VGST for sort of and helping us set this up and initiating the project. So this is a quick overview. I did want to talk about the agenda. What is it that you'll be covering in the next 4 days? But before that, any questions? Okay. So let me just talk about what is our plan. We have almost about 13 to 14 sessions in next 5 days. I just talk about the overall program. Ritesh will take you through the whole development architectures, the software installation. We had shared with you, what are the packages that have to be installed on each of your machines. Then we'll go into introduction to VR. So, spinning a 3D cube, which essentially would be done by Ritesh. Then, we'll build a Modelica model in, a bouncing ball model in Modelica. So that will give an introduction to Modelica, which is the simulation engine, which would be covered by Ritesh and Ajaya. Then we'll also sort of interact, build the equivalent model in CodeSys, which would be done by Ajaya, and also how do you interface the two together. Okay. Then we'll give an introduction to Blender, which is basically, we'll make a small 3D ball, which would be basically taken by Ritesh and Monisha. And then, how do I convert this ball into something which is programmable? So we'll do a little bit of scripting, which will be taken by Ritesh. Then we'll go on to more detailed model of Modelica. Here we just give an introduction to Modelica with bouncing ball. Here we'll talk more about the interacting model. And then we have a nice session on mental and emotional development, etc. And then finally, I think Dr. Desai. Yeah.
One participant, Miss Radha, please, can you please?
Yep.
Yes, sir.
Thank you, sir. Yeah. So when you're talking of control, it's very nice to get the feel of it. So you basically got a touch and feel of or the sound of positive feedback. So which is good. Okay. So then we'll get on to we'll have Dr. Desai who will take us through the whole interacting tank and the VR setup which is present in BMS College. And then we'll do some amount of VR interacting tank hands-on sessions so that you sort of get the touch and feel of it. And finally, we have a small sort of a competition or a hackathon, which sort of will help you to sort of get much more immersed into the program. So this is a quick overview of the activities also which we have planned. I would like to thank my colleagues, Ritesh, Ajaya, and Monisha, and of course Dr. Desai, who have worked quite a bit to sort of get this whole, all the sessions up and running. I am done for, I kept last 15-20 minutes for question and answers. So we can have a session, if any questions, we can talk about it.
Yes, sir. Participants, if you have any questions or if you have any clarifications, you are free to.
Can you hear me, Sunil?
Oh, yes, sir. I can hear you.
Yeah, I would like to know whether the participants' preparation point of view for the hands-on sessions virtually, apart from the software installation, whatever was given by Santosh Desai, any other preparation required or that is enough?
Well, what we are given is enough. So, as long as all that packages have been installed, we don't expect any a priori knowledge, programming knowledge, etc. for this session. So,
Okay.
we have created some small, easy to use modules, etc. So, you should be able to use them directly. Ritesh, you want to add anything to that?
Yes, sir, what you said is right. Means the general understanding of how a logic works is enough. No language specific knowledge is required. We'll go through it. And, yeah.
Yeah, Ritesh, I sent a mail that maybe it is particular to me. I had some problem
Yes,
in
sir.
installing
Yes,
the
sir.
proper.
So next session
You,
is about discussing if anybody is
okay,
having any problem in installation, so we can take it.
okay, thank you. Yeah, that's all from my side.
Okay. There's one more question. As I know I belong to CAC and don't have any idea about PLC. Do I need to have some fundamental practice? Not really. So PLC is basically just a framework in which you can sort of get some data and something goes out. So it has a controller, but you don't really need to know the details of the PLC. So but I think with your computer science background, conversion from Blender to Unity 3D, understanding Open Modelica, that would be very fast for you.
Good morning, sir. Sunil sir.
Yes, sir.
From BMS. Sir, is the chemical reactors are restricted to only the liquids, or can even
You can do a gas phase reactor, you can do a liquid phase reactor, you can do a bioreactor. So basically in Open Modelica, it gives you this capability of putting in your own models. So in fact, we have used Open Modelica for a whole variety. We have sort of built models for distillation column, for bioreactors, for packed bed reactors, packed bed adsorbers, etc. So there is really no limitation. You can build not only chemical, you can build an electrical model. You can build. We have actually built an UAV model also using Modelica. There's a whole variety of models you can build. For Marvel UI, not really. Basically, if you have your own Android phone, that is good enough. Otherwise, nothing else is required at this moment. When you get into the UI development, app development, of course, you will require those packages, but that would be advanced level. So, we'll not go into that detail at this moment.
Any more questions from the participants? Dr. Sunil sir, one question I have in my mind, which is which may be there in the participants' mind as well. So suppose if a faculty wants to explore what is there in AR VR, so what is the starting point for him?
So this, in fact, sir, this is the starting point. So we would be covering the basic fundamental technologies or the basic building top blocks to start AR VR. So what Ritesh, Ajaya, and Monisha will take you through are the critical components. Blender, Unity 3D, simulation, communication between all that. So those are the basic building blocks for you to get started on AR VR. Okay. So that is when you want to build your own AR VR framework. If you really want to just experience AR VR like a gamer, then you just need to get a VR headset, and there's quite a bit of packages available that you can download and use. There's I hope that answered your question, Dr. Professor Desai.
Yes, sir. And there are a couple of questions in the chat box,
Yes.
sir.
I'm
Yes, sir.
looking at that.
Yes, sir.
No, it is not really necessary to use i5 or i7 for the moment. Of course, as you go into more advanced development.
Dr. Manisha, madam, can you please mute your mic, madam?
Yes, sir. Because
Please.
Okay. So, when you go into your own development environment, etc., then of course, some of these packages are compute heavy. So it is better to use i5 or i7. But for this workshop, you should be good with i3. And I think that also answers the question on hardware requirements. I think Ritesh would have mentioned in the setup, i3 and beyond should be okay.
Ritesh is here?
Yeah, yes, sir.
Yes, sir. Yes, sir.
Yeah, so I5 is because the faculty would be running various softwares in parallel. So that's why it was mentioned that I5 and beyond. And as I had mentioned in the note that I3 will also work, but running all those applications in parallel may halt the system. So that is one possibility, not necessary. But yeah, I3 or I3 also it works, but because we are running online video session also, and then all those applications also now, so it may halt your system. Otherwise, we are okay.
Okay. Thanks, Ritesh.
Dr. Manisha, madam, do you have any questions to ask?
yes, sir.
Yeah,
Thank you.
please go ahead, madam.
Thank you. Sunil, sir,
Yes, ma'am.
can you please highlight few of the biomedical applications?
So in fact, there are quite a bit. So you can use it for you can create a simulation model. In fact, people have done that also. So they have created a simulation model of different components of human bodies, etc., and use them for training people. So that's that's one experience that you can do. You can that's on the biomedical. So quite a bit of human intervention technologies can be built on VR world and demonstrated. So it's actually been quite heavy in the biomedical bioreactor world for applications.
Thank you, sir.
We personally
Yes,
have not used it much, but it's quite a bit. Ritesh, you want to say something?
yeah, just to add on to that, even in biomedical electronics, for example, operating all the heavy machinery that you have in hospitals. So doctors use this those VR applications to just get a hands-on before they operate an actual patient with those machines. And so that is also one of the applications.
Thanks.
Thank you, Ritesh.
Any further questions?
Sir, there is one question raised by TechFord to test the application.
I think that was linked to that hardware question. So
Any
that
hardware
so all that got covered together.
Okay. So any more questions from the participants?
Okay. So if there are no further questions, we can take a small break, and then we'll start with the development architecture by Ritesh. In the meantime, sir, you were saying something?
Yes, sir. Yeah, I want to thank you. So,
Okay.
yeah, you complete your session. Then I would like to say some few words.
Sure. So, my sincere recommendation would be, please do make it a point to attend all of them, and really get into the hands-on, because at the end of the day, everything that we want to learn, is basically by doing. So either using VR or actual. So the main thing would be sort of installing all the packages, doing the basic exercises that we have given or will be giving, so that you get the hands of it, and the feel of it, and wish you all the best. Sir, I'm done. Yeah.
Yeah. Thank you, Dr. Sunil, sir. So for his giving an insight into what is this AR and VR, how it is going to work, and how it will be useful in the process industry, and also giving a glimpse of the overall event once again. So with this, we will end the session 1, and we will take a short break, and we will resume the session with Mr. Ritesh, who is going to speak on the development architecture and the software installation related to the topic. Okay. So with that, we will have a short break, and we will be back at 5 minutes prior to 11:45. Thank you. Thank you, one and all.
Thank you, sir. Bye, everybody.